Welcome to the second video covering solving rational equations. In the first video for this topic, I went over just all of the core ideas for how to solve these equations. So just to give you a quick run through again, for those of you that watched that video but maybe are a little bit rusty, the first thing you want to do is find your common denominator. Then you want to get all of your fractions over that common denominator. Then once you have that, you're actually just going to get rid of the denominators completely. And then whatever's left is what you're going to solve. So in this video, we're not going to be seeing really anything new. It's just going to be looking at more complicated, slightly more challenging questions. And we're only really going to do a couple. It's just a chance to practice and get a little bit deeper into things. So we've already got one up here. 3 over x squared minus 4 minus 1 over x squared plus 6x plus 8 equals 5 over 2x squared plus 4x minus 16. So we're going to go through this whole thing and see how it goes. So the first thing we want to do is to factor these denominators. So that first one is a difference of squares. It's going to factor to x plus 2 times x minus 2. The second one is going to factor to x plus 2 times x plus 4. And the third one, we actually have a common factor that we can take out here. So if we take out a 2, we're left with x squared plus 2x minus 8, which once we factor fully is going to factor to 2 times x plus 4 times x minus 2. And so if we look at all of these, there's a lot going on here. Our common denominator is going to have an x plus 2 and an x minus 2 because we already had those in our first fraction. If we look at the second fraction, we still have an x plus 2, but we do need an x plus 4. And then if we look at our third fraction, we've got an x plus 4, we've got an x minus 2. Those are both good, but we do need that 2 that we pulled out as a common factor. And so that is my common denominator. From there, we're going to go to each of our fractions, and we're going to multiply them by whatever it is they're missing. So our first fraction is missing both the 2 and the x plus 4 from that common denominator. The second fraction is also missing the 2, but it's missing the x minus 2. So that's what we're going to have to multiply here. And our third fraction has the most things in it. So it's got the 2, it's got the x plus 4, it's got the x minus 2. But it is missing one thing, which is just x plus 2. So we've given each fraction whatever it's missing, but now we actually have to go through and do all those multiplications. So a quick reminder for this first one here, I mentioned this back in the multiplication video, but I'm going to mention it again here. When you're multiplying things like this, make sure you multiply the things outside of the brackets, so just the 3 and the 2, before you worry about what's in the brackets. So we're going to do 3 times 2, and we're going to get 6, and then we're still going to have that x plus 4 there. Same for the second one, so we're going to do 1 times 2, which is just going to leave me with 2 times x minus 2. And we can't forget our common denominator here. So that's going to be 2 over x plus 2 times x minus 2 times x plus 4 for both of these. And then on the right side of the equation, we've got 5 times x plus 2, which is just going to be 5x plus 10 over 2 times x plus 2 times x minus 2 times x plus 4. So we do still have a little bit of work to do here, but since we've got denominators under all of these and they're all the same, I'm going to cancel these all out now because I really don't feel like having to write those out one more time. And so if we multiply everything that we've got, on the left, 6 times x plus 4 is going to get me 6x plus 24. 2 times x minus 2, keeping in mind that we do have a negative here, so we are going to have to be really careful with this negative. We're going to get 2x minus 4, and we're going to have to remember we are subtracting that entire thing. And on the right side, we've just got that 5x plus 10. So if we combine the stuff on the left side, right, because that's typically a good idea. So we've got 6x minus 2x, which is going to be 4x, and we've got 24 minus negative 4, which is going to be 28. On the right side, we've still just got 5x plus 10. So what some people will do is they'll actually think of this, instead of being subtracting this whole thing, they'll instead treat that basically as just a negative 2. And so if you do negative 2 times x, you get negative 2x, and negative 2 times negative 4 would get you positive 4. And that's totally a valid way to do things, just be careful. All right, we've got ourselves down to just an equation. We've got multiple x terms, so we want to move all of those to one side. So I'm going to subtract 4x on both sides. We want to move the 10 over to the other side, so I'm also going to subtract 10 on both sides. And so on the left, that's going to leave me with 18. On the right, that's actually just going to leave me with x. And so we're done. We've got x equals 18. The only thing we need to consider now is our NPVs. So we've got x cannot be negative 2, positive 2, or negative 4. Our answer isn't an NPV, so we don't have to discard it. It's pretty good. And so there we are. That one's finished. So you can see it's just a lot going on. It's not really any different from what we did in the last video. There's just a lot of things to keep track of and a lot of places where you could mess up. So you just have to take your time, go through things slowly, and make sure you're doing it right. All right, so one more of these, just a chance for you to practice for yourselves. So you're going to solve this one, and you're going to give your answer, and this is going to be something you haven't heard in a while. You're going to give your answer as an exact value and also as a decimal. And so if you stop and think about what that means, you'll probably be able to figure out where this question is taking you. So here's your equation. It's 1 over x minus 1 plus 2 over x squared plus 7x plus 10 equals 3 over 2x plus 4. So away you go. Pause me here and give it a shot, and then be really careful. Once you've got yourself down to your final answer, come back and see if it's right. All right, so as far as denominators go, our first one is already fine. Our second one is going to factor to x plus 2 and x plus 5. Our third one is going to factor to 2 times x plus 2. And so our common denominator needs to have an x minus 1, needs to have an x plus 2, and an x plus 5. So that's from the first two fractions. For the third one, we've already got the x plus 2, but we do still need, again, that common factor of 2. All right, so there's a lot to do here. Our first fraction is missing several things. So we've got 1 over x minus 1, but it's missing the 2, the x plus 2, and the x plus 5. The second fraction has the x plus 2, has the x plus 5, but it's missing the 2 and the x minus 1. And make sure you're multiplying these on the top and the bottom. Don't get sloppy like I was there. Oops. And then our third fraction, and you can see that these start to take up a lot of space on the page, is going to have the 3, it's going to have the 2 and the x plus 2, but that means it's missing the x minus 1 and the x plus 5. All right, so I'm going to save myself some heartache and just get rid of all of these denominators now. Normally I wouldn't mind writing them all out as clean denominators, but it's just a lot of writing, so let's speed up the process here. All right, so for our first term here, we are going to multiply the 1 and the 2 to get 2, and we're going to multiply these two brackets together. So we're going to FOIL here really carefully, right? So x times 5, 2 times x, 2 times 5. So when you FOIL and simplify, what you're going to end up with is x squared plus 7x plus 10. For my second term, we're going to do 2 times 2 to get 4. And then the x minus 1 is just going to stay there for a sec. Then for my third term, the 3 is the only thing on the outside of the bracket, so it's going to stay there for a second, and I'm going to FOIL these two binomials here. So once I do that and simplify, I'm going to get x squared plus 4x minus 5. And so I've done, well, some of my stuff. I've still got a bunch more to do. So let's distribute all of these things. Once we've done that, we end up with 2x squared plus 14x plus 20 plus 4x minus 4 equals 3x squared plus 12x minus 15. We can combine some like terms on the left side here. So 2x squared is just going to be 2x squared. 14x plus 4x is 18x. And then the 20 minus 4 is 16. On the right, there's not much to do yet, which gets me here. And then, so this is quadratic, right? Which means we want all of our terms to be on the same side. In this case, it's actually going to be better for us to move everything to the right side of the equation, because if you're looking at your x squares, it makes more sense to have positive x squares, which means we want to move the 2 over to the 3 instead of vice versa. So we're going to subtract 2x squared. We're going to subtract 18x. Oops, and it looks like I forgot my x here, so make sure you have that. So this should be 18x, not just 18. So we're going to subtract 18x on both sides. And we're going to subtract 16 on both sides. And so once I've done that, the left is just canceled out completely. On the right, we've now got x squared minus 6x minus 31. And so we want to solve this. It is quadratic, which means we either want to factor, which isn't going to work here. Nothing's going to multiply to 31 and add to 6. Or we probably want to use the quadratic formula. It's been a while since I've used that in any of my videos, which means it's probably been a while since you've seen it. So just a quick refresher on it. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we start plugging stuff in, that's going to be x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 31 all over 2 times 1. We're going to simplify everything we can here. So negative 6 is positive 6. Negative 6 squared is 36. Negative 4 times 1 times negative 31 is going to be plus 124. And all of that is over 2. And so we're left with now 6 plus or minus the square root of 160 divided by 2. And so our question asked us to do exact values and decimals. And so here's where things get a little bit more annoying. Since having done this back in chapter 4, you've actually learned how to work with radicals like this root 160. And so there is something we can do with this. If we take this root 160, we can probably write this as a mixed radical. So your prime factorization of 160 is 2 times 2 times 2 times 2 times 2 times 5. And so just a quick refresher, remember you want to make groups of 2 equal factors. So in this case, we can pair up a couple of 2's. We're going to pull those out, which is going to give me a 2 and a 2 on the outside, and a 2 and a 5 left on the inside, which is going to turn that root into 4 root 10. So coming back to what we had here, this is now going to be 6 plus or minus 4 root 10 over 2. And so this is something we can simplify. So I've talked in the past that you can't simplify unless you can simplify all of your terms, but everything here, not including the 10 because it's inside the root, but everything else is divisible by 2. So if we divide everything by 2, we're going to get 3 plus or minus 2 root 10, and then the denominator is just 1, but I don't care about that anymore. And so there is my most simplified version of my answer. So my two solutions are x equals 3 plus 2 root 10, and x equals 3 minus 2 root 10. We also wanted decimal answers, so if we plug those into a calculator, we're going to get 9.32 or negative 3.32. And so there we are. That is our final answer for this, except we do still need NPVs. So x cannot be negative 2, negative 5, or positive 1. So as promised, that was quite a bit more challenging. There was a lot going on there. We didn't end up with any extraneous roots, right? So that is something you do still need to keep an eye on for. But we had a lot of other things that we need to work with. So that's how you solve rational equations. In the next video, which will be the last one for this chapter, I'm going to just go over a couple of specific types of word problems that do use rational equations that do tend to give people quite a bit of trouble. So once you're ready, go take a look at those and you can wrap up this chapter.